Hello and welcome to part 2 of lesson number 2 in Unit 0 Algebraic Tools in our grade 11 University College math class. This is the introduction to factoring. We do common factoring and simple trinomials. In part 1 we went over common factoring, which I'm not going to review here. Let's get on to simple trinomials. So a trinomial, of course, has three terms, ax squared plus bx plus c, and we call one simple where the a value is equal to 1, which means that there's really no visible coefficient in front of the x squared term except a 1. We're going to explore how to go about factoring a simple trinomial by looking at two binomials being expanded out. So we're going to do this here quickly. We're going to expand this out. We did this in the last lesson. X times x is x squared plus 5x plus 3x plus 15. And gathering together the terms that are alike, we end up with x squared plus 8x plus 15. So there's our first template. Again, here we have a simple trinomial that resulted in the expansion of two binomials. So that's a clue for us. Let's have a look at the next binomial. Let's expand it out. W times w is w squared plus 3w minus 4w and minus 12. Again, gathering together the terms that are alike, we have w squared minus 1w minus 12. Again, a nice, beautiful, simple trinomial here resulted from the expansion of two binomials. And let's do the last one. Z times z is z squared minus 6z minus 1z and plus 6. Gathering together the terms that are alike, z squared minus 7z plus 6. Again, nice simple trinomial from expanding out two binomials. So what we're looking for here is a patterning. It's fine to go from two binomials out to a trinomial, but how would we be able to come up with sort of an idea of how to go backwards? How do I go from the trinomial to the two binomials that started it? So what we're looking for here is patternings. And the numbers that we would be given, of course, would then be the 8 and the 15. So we have 8 and 15, positive 8 and positive 15, I guess specifically. And if we look at the numbers that we have at the end, we have a plus 3 and a plus 5. So how are those going to be related? Well, without sort of spoiling it too early, the idea here is that the two numbers we have at the end, those two numbers must multiply to plus 15, our last number, and they must add to our middle number, our plus 8. And this is true of both, because remember, we had a plus 3 and a plus 5. If you combine them, add them together, you end up with negative 8. And if you multiply them together, you end up with plus 15. So that's how the patterning works. Let's see if it holds true over here. So what we're looking for is two things that multiply to our constant value, that multiply to negative 12, but that add to our b value, the middle value, which is negative 1. Let's have a look. It's minus 4 and plus 3. So indeed, when we multiply them together, we end up with negative 12, and when we combine them or add them together, we end up with negative 1. So far, so good. Last example. So we're looking for two numbers that multiply to give us our constant value, plus 6, but which when added together give us our b, or middle value. That's negative 7. Let's have a look. So that is minus 1 minus 6. When multiplied together does indeed give us plus 6, and when added together or combined gives us negative 7. So that is the piece that we want. We're looking for two integers that will become the numbers inside the brackets, the two binomials. We're looking for two integers that multiply together to give us the c value, the constant, and which when added together give us the b value. That's the one in the middle on the linear term. So let's see if we can figure this out. If we have y squared plus 7y plus 10, we're looking for two things that multiply to plus 10, which, when added together, give us plus 7. So if we think about all the things that multiply to plus 10, hopefully one that pops to mind right off the bat will be plus 5 and plus 2. And that works. Plus 5 times plus 2 gives me plus 10, and plus 5 added to plus 2 gives us plus 7. So how do we write this out? Well, let's start with two brackets. Because this is a y squared here, each of these brackets will start with a y, and then we put one of these two values, plus 5, in the first bracket and the other of those two values in there. You don't have to write it in this order. You can write it as y plus 2, y plus 5. That is also just fine. So that is how you factor a simple trinomial. Let's do a couple more examples here. Here we have a squared minus a minus 6. So we want to find the pair of integers that multiply to give us negative 6, but that add together to give us negative 1. So again, the negative 6, the constant, and the negative 1, the coefficient in front of the b term or the middle term. So let's think about this. Negative 6, and a negative 1 is what we have. So we have 6 and 1 and 3 and 2. I think negative 3 and plus 2 will work. When we multiply those together, we do end up with negative 6. And when we add them together, we end up with negative 1. That's looking great. So again, in our brackets, two brackets, a squared at the beginning, so each of these brackets is going to start with an a. One gets the first term, let's say negative 3, and the second bracket gets the second. Again, order's not important. Could be a plus 2 and then a minus 3. It doesn't really matter. Last but not least, x squared minus 6x plus 9. So we're looking for two things that multiply together to give us plus 9, which when added together give us negative 6. All right, this is trickier a little bit. So 9 and 1 won't work. 3 and 3 won't work, but negative 3 and negative 3 will work, in that two negatives multiplied together result in a positive integer, so that will give us our positive 9, and when they're combined, they'll give us negative 6, which is awesome. So let's start a couple of brackets. Because we have an x squared here at the beginning, we're going to start each bracket with an x, and each bracket gets a negative 3. Now, special case here, if the two binomials are identical, the most fully factored way to write this is as a single binomial all squared. And that is factoring simple trinomials and common factoring. So good luck with the homework. If you have any questions, obviously email me, reach out. Our in-class video chat that's open every day. Come see me in that. Come see me in person if you're in the classroom. Otherwise, good luck on the homework, and we'll see you in lesson number 3.